Hi, so this video is going to be on adding and subtracting rational expressions. So we've already covered simplifying rational expressions as well as multiplying and dividing rational expressions. Now we're going to work on adding them. Before we get started with example 1, let's just be reminded of adding and subtracting fractions together. This is section A5 part 3. So adding and subtracting rational expressions. If I wanted to add 1/2 plus 3/2, I could go ahead and add these. They have the same denominator, and because they have the same denominator, I can go ahead and add them together right away. When we're adding and subtracting fractions, we have to have a common denominator. Once I do have a common denominator, I can just go ahead and add the numerator plus the numerator. So 1 plus 3 is 4. The denominator is just going to stay that common denominator. So this would equal 4/2, which simplifies to 2 over 1, or 2, right? If I wanted to add two fractions that do not have the same denominator, so if I wanted to add 1/2 plus 3/4, I need to first get these denominators to match before I can go ahead and add. So the way I'm going to do that is I'm going to think about what 4 and 2 have in common. So 4 is just 2 times 2, right? So in order to get this denominator to match that one, I would have to multiply it by 2. But it's not like I can just go around and multiply a denominator by a fraction by another number and expect it to be the same, right? 1/2 is not equal to 1/4, which would be if I just times the bottom by 2. So to counteract that, I have to also multiply the top by 2. So I'm not changing the fraction if I do this, because I'm really just multiplying it by 1, right? Because 2 over 2 is just like a fancy way of writing 1. So I'm really just multiplying it by 1, but now I'm going to have a common denominator. So this 2 times 1 is 2, and 2 times 2 is 4. So 1/2 and 2/4, those are equal, right? But now 2/4 is a form that has that common denominator with 3/4. So now I can go ahead and add that together. So 2 plus 3 is 5 over that common denominator of 4. Okay. If I wanted to subtract two fractions, I could do that as well. So if I wanted to subtract 7/5, say, or I wanted to do 7/5 minus 2/10. Again, my denominators don't match, so I need to get them to match. This one reduces to 1/5, so I could do it that way. The other way is to multiply this side by 2 over 2. So whatever the bottom needs to be multiplied to make it match the other denominator, just multiply it by the top and the bottom. That way it will keep the fraction the same because you're just multiplying by 1, but it will give you that common denominator. So 2 times 7 is 14, and 2 times 5 is 10. So this would be the same as 14 over 10 minus 2 over 10, which equals 12 over 10. Now, once we have our result, we can reduce it. The one thing to be careful about here is to remember that once we have that common denominator, we don't combine denominators at all. We just keep it the same for the answer as we do for our individual pieces, and only the top gets added or subtracted. And then 12 over 10, that's 6 times 2 over 5 times 2, so those 2's will cancel out, and I'm just left with 6 over 5. Okay, so let's keep that in mind. We're going to do similar things here, but now we have rational expressions. So the first thing I'm going to do when I get one of these questions is I'm going to look at the denominators. And it looks to me like we already have common denominators. So 10xy cubed, 10xy cubed. So those are the same already. So because of that, I'm going to just combine the answer to this problem over that common denominator. There's nothing I need to do in order to get a common denominator. And I'm just going to go ahead and do this problem across the top. So it's just going to be 5x plus 2y plus x plus 2y. So 5x plus x makes 6x, and 2y plus 2y makes 4y. So 6x plus 4y over 10y cubed. Now this is these two expressions added together. I do want to look through them and make sure there's nothing else that I can cancel out or simplify. Remember, if you have a plus between two terms, I cannot just cancel out half of a plus or minus. So I can't cancel out these two x's, because of this plus. What I can do is look for common factors in these two terms, which I know that 4 and 6 have a common factor of 2. So I could pull that 2 out front, which would leave me with 3x plus 2y. Good. Let's do this. So 3x plus 2y. If I erase part of it, it will all go away. And then down here, I know that 10 is equal to 2 times 5, and then I have times x times y cubed. So I know those 2's will cancel out, and it looks like nothing else will. So I'll have 3x plus 2y divided by 5x y cubed. Okay. So this is my reduced and simplified addition of these two terms. So let's try another one. Maybe. Okay, let's go back to number 2. So again, I have a common denominator already. I have 8y and 8y, so I don't need to worry about getting a common denominator here, which makes my life a little easier. But I do need to go ahead and subtract. Now notice, these division symbols, these are grouping symbols, right? So that means that 2x minus 4 is grouped, and it means that x plus 4y is grouped. So keep that in mind as we're doing this, because basically what we have here is a binomial minus a binomial, and I need to think about that minus and what it's going to do to 2x and negative 4y. So I know that because of that common denominator, my denominator in my result is just going to be 8y. And then across the top, I'm just going to have this little expression. So just kind of write it down from across the top. But again, make sure when you have, especially when you have a minus in here, that you're thinking about this 2x minus 4y as a group, because we want to make sure our signs are correct when we have that minus in there. So now I need to simplify across the top. I know that if I have a minus between two polynomials, that negative needs to be distributed to both of the top terms. So this is going to give me, I'm going to just rewriting the first part, x plus 4y, and then this minus will come and make this a minus 2x, and then minus times minus gives this a plus 4y over 8y. Okay. So now I can go ahead and combine like terms across the top. I have an x and a negative 2x, so x minus 2x is negative x, 4y plus 4y is 8y, and that's all going to be over 8y. Okay, now I know some of you are going to be tempted to cross this 8y out because they match, but remember you cannot cancel something out unless it's a multiple. So this plus right here makes it so that 8y cannot be canceled because it's only half of this negative x plus 8y. So be really careful with that. You can always cross them out if they match, if they're multiplied by the things next to it, but if they're added or subtracted, you need to make sure that the entire thing matches before you cancel anything out. So negative x plus 8y over 8y would be the result here. Alright, so let's go ahead and try another one. We'll advance to our next example. So now look at this one. There is 3m squared n on the numerator here and 2mn here. So we're missing some things. These denominators do not exactly match. So I'm going to write them out so that I can see every single factor that's here. So I have 3 times m times m times n on this side, and on this side I have 2 times m times n. So I see that this side is missing a 2, and this side is missing an m and a 3. So because of that, I'm going to multiply both sides of this fraction by the things that are missing on this side. So again, 3m divided by 3m is just 1, so I'm not changing the fraction, but I'm just making it so that this side and this side will match. Over here, I have just the 2 missing, so I want to multiply this side by 2 over 2. So let's go ahead and simplify here. 2 times 5n is 10n. 2 times 3m squared n is 6m squared n. And then I'm going to do the other side. So 6 times 3m is 18m. And 2 times 3 is 6. And then I'll have the m times m, which gives me m squared. And then m. So now they match. I gave each side the things that they were missing. And now I can go ahead and finish the problem. So because my denominators match, I can just go ahead and combine this whole thing over that common denominator. 10mn plus 18m. Those are not like terms, so I can't actually add them together, but I can go ahead and put them together over the same denominator. Now, I'm not quite finished yet because I see that 10 and 18 have some common factors with 6. So I'm going to go ahead and factor the common factor out of the top. So the greatest common factor between 10 and 18 is 2. So I'm going to pull out a 2, which will leave 5n plus 9m. And on the bottom, I am going to see that 2 times 3 is 6. And I'm going to cancel the 2's. So here's the simplified subtraction or addition problem. 5n plus 9m over 3m squared n. Okay, so let's try another one. Okay. So again, I'm looking to see in the denominator what the terms are missing. 4 and 3 don't have any common factors, so I know I'm going to need to multiply this side by 4 over 4, and I'm going to need to multiply this side by 3 over 3. Okay. Now I know there's other things I'm going to have to do because this side has x squared and y, and this side only has x. So I need to multiply this side also by x times y over x times y. Okay, that will give me the 4, the x squared, and the y, and it already had a 3. So it will have everything the same on both sides if I multiply this side by 3. So now go ahead and simplify. So 3 times 3 is 9. 3 times 4 is 12. So this side becomes 9 over 12x squared minus y. This other side I have 6x times 4xy. So the 6 and 4 is 24. X times x is x squared. And then y. And on the bottom, 3 times 4 is 12, and x times x is x squared times y. Okay, now I'm looking for, or now that I have common factors, I'm just looking to combine this into one problem. So I'm going to have 9 minus 24x squared y. And then I'm going to look for common factors. So 9 and 24 have a common factor of 3, so I'm going to pull the 3 out front. That's going to give me 3 minus 8, no, 24 divided by 3, yes, that's right, is 8, x squared y. And then 12 is 3 times 4, right? So those 3's can cancel. So I'm just left with 3 minus 8x squared y over 4x squared y. Okay, so get the common denominator. Go ahead and do the subtraction across the top, and then see if you can simplify at the end. All right, let's try another one. So on this one, the only thing that I can factor is this 12x squared plus 36x. I do want to factor this before I try to get the denominators to match, because I want to see if they have any matching factors. That's going to make things easier. So everything's going to stay the same here, except for that 12x squared plus 36x. I'm going to factor that. I'm going to pull out the greatest common factor, which would be 12x. 12x, if I pull that out, that's going to leave x plus 3. So now I can see that both denominators have x plus 3, but that this side is just missing the 12x. So I'm just going to multiply both sides by 12x over 12x. And then I'm going to have a common denominator. So now I can go ahead and simplify everything. 5 times 12 is 60. So 4 plus 60x on the top over that common denominator of 12x times x plus 3. Now I see that 4, 60, and 12 all have common factors, so I am going to pull that 4 out on the top, which will leave 1 plus 15x. And then I'm going to cancel it with, or I'm going to reduce the 4 over 12, because that's 3 times 4, right? So the 4's will cancel. I'll be left with 1 plus 15x divided by 3 times x plus 3. Okay, so that would be as simplified as I can get it right now. All right, so on this one, notice I have one denominator that's n plus 3 and the other that's n plus 4. Now I might notice here that they have an n in common, but it's not the right kind of common factor because it's not multiplied by things around it, it's added. So I have to think of this n plus 4 as one number and this n plus 3 as another number. So I can't consider that n like the same factor because factors are multiplied by things around it. So in this case, because there's nothing common in the two denominators, I'm just going to have to multiply each side of this by the other or the opposite denominator. So this one's going to get multiplied by n plus 4 over n plus 4, and the other one n plus 3 over n plus 3. Now on my denominator, I do not need to FOIL this out or like distribute this out and multiply it together. I can just leave it as n plus 4 times n plus 3. Okay, you don't need to go to the work to get that all multiplied together. This is my common denominator. Now I'm going to do the problem across the top. So this 6 needs to be distributed to both of these numbers, so that would be 6n plus 24. Now this negative right here means that this 5n is negative. So when I distribute this one in, I got to make sure I'm distributing that negative 5n. If there's a minus in here, make sure that it's being carried through to everything up here. So negative 5n times n is negative 5n squared, and negative 5n times 3 is negative 15n. So now I can just look through here and kind of simplify as much as possible. I'm going to put the top in standard form. Negative 5n squared will come first because it has the highest exponent. Next I'll have the 6n minus 15n, which comes out to negative 9n, and then plus 24. And that will be all over n plus 4 times n plus 3. Okay, so that's my answer. Okay, let's try another one. Here, I see that this part down here may need to be factored, and I want to always factor things first because I don't want to just multiply all this mess by this side. I want to see if they have common factors first. So I'm going to pull out the 4n here, and that is going to leave me with n plus 3. Okay, so in this case, nope, I don't have any common factors. On this side I have n plus 6, on this side I have 4n times n plus 3, which means, again, I just have to multiply this by the entire thing. If there's no common factors, the whole denominator needs to be multiplied by the whole denominator. If you're just missing some factors, you can just do the one you're missing. So this side is going to need to be multiplied by n plus 6 over n plus 6. See, so now both denominators have all three of those factors. So we need to make sure that that happens to get our common denominator, which is 4n times n plus 3 times n plus 6. On the top here, this 4 and this 6 can get multiplied together, which is 24. So this is the same as 24n times n plus 3, and then I'm going to distribute this in. So that's going to give me 24n squared plus 48, 58, 68, so 72n. And then over here, remember, there's a negative here, so that means when I distribute this negative 6n, or this 6n into these parentheses, I need to make it a negative 6n. So be really careful if there's a minus between. Negative 6n minus n is negative 6n squared, and negative 6n times 6 is negative 36n. So now we can look for like terms and combine them. Negative 6n squared and 24n squared, that would be 18n squared. And then 72n minus 36n would be minus 36n. All over the 4n times n plus 3 times n plus 6. Okay, so now I can see that 18 and 36 have a common factor of 18, so I can pull out the 18. I'm running out of space here, so maybe I'll erase this part over here. So now we're going to go ahead and pull out the greatest common factor. We're just trying to simplify now as much as we can. I can go ahead and pull out that full 18n, and that will leave me with n minus 2. Okay, so still none of my pluses or minuses here are going to cancel out, but the n right there will cancel with that one, and these are both divisible by 2, so this is going to become 9 over 2. So 9 times n minus 2 left on the top, 2 times n plus 3 times n minus 6 on the bottom. Okay, so go ahead and try some of these. If you have questions, let me know, and good luck.